Everybody, this is video 2 of the exit ticket debrief. This was my first solution to the exit ticket. I use this for loop to loop through all the possible starting numbers that could begin a sequence. So numbers starting at 2 going up to 1,000. And then for each starting number, this box has a loop that will generate all of the numbers in the sequence that start with that first value. And the way that I know I'm done is I need to keep generating numbers until eventually I reach 1, because the sequence doesn't end until you've hit the 1. And so that's why I say while I haven't reached the 1, I know I'm not done yet. And I'll do this process of generating the next number, and then I have a counter to count how many numbers I've generated. And then once all of that's finished, once the most recent number I've generated is 1, I'll exit the loop and I test if the number of terms in this sequence is larger than 100, and if it is, I add to the counter. So I'm going to do another solution now, which I imagine a lot of you might have tried to do, which is more similar to the classwork where you were using an array list to actually save all of the numbers in the sequence. Just to show you that you can do that also. But I think this, for me, is sort of a cleaner solution because there's no real reason to save those intermediate numbers. Okay, so I'll start the same way. I'm going to loop over all the possible starting values from 2 to 1,000. And then I'm thinking I'm going to have a chunk of code here whose job is to take the starting number and generate all the rest of the values in the sequence. Only this time, I'm going to make an array list of integers, which I will call vals equals new array list. And each new thing I create, I'm going to put in the vals list. So I'm going to start by adding that first value to my vals list before I even start the loop that generates the other ones. So in the other video, I said we don't actually know how many terms we're going to have to make before we get to the 1. So if we knew how many times we were going to repeat, we'd use a for loop. Because we don't know how many times we're going to repeat, I'm going to use a while loop. And I know that I want to keep generating terms as long as I haven't reached 1. So the most recent number I generated is going to be the last thing in the vals list. So I'm going to say vals.get. And now I need a way of saying what's the last thing in the vals list. Let me draw a little picture over here. So let's pretend I've gone through a couple of iterations here. And my vals list contains like 3, 10, 5. If I say vals.size, that's 3. But the location of the last thing is vals.size minus 1. And that's always true for arrays and array lists. The last location in the list, the last index, is always 1 smaller than the total number of things because we start counting at 0. So if I want to get out the last thing in the list, I'll say vals.size minus 1. And then let me put a little box here so you can see this vals.size minus 1 is a location number. And I'm saying let's get the value at that location number. And I want to make sure that it's not equal to 1. Because if it's not equal to 1, that means I want to keep going. Okay, so what's going to happen next? Let's define an int called next. That I'll just initialize to 0, but now I'll compute it from the previous value using the rules. I don't want to write vals.get vals.size minus 1 a lot. So actually, let me insert a line right here. Right in there, I'm going to insert an integer called previous, and it's going to be equal to vals.get vals.size minus 1, and that's all. So this most recent value in the list, I'm going to get it out and save it into a variable called prev because it's much shorter to write the word previous than it is to write this whole thing. Okay, so what were the rules? The rules were if the previous number was even, so if the remainder when I divide it by 2 is 0. In that case, next is going to be previous divided by 2. Otherwise, that means it has to be odd. So next is going to be the previous value times 3 plus 1. Those were the rules from the slide. Okay, so now this if-else statement has generated the next term in the sequence, and I want to add that to the end of my list. So I'll say vals.add next. And that's the end of my while loop. And so now I'll go back up to the top and I'll get out the new last thing in the list, which was this next that I just added a second ago. And if it's not equal to 1, I'll do it again and add the next term. And I'll do it again and add the next term. And eventually, next is going to be equal to 1. And then I'll come up here. And because the most recent thing I added is equal to 1, this will be false, that it's not equal to 1. And so I'll exit the while loop. Okay, in this case, I don't need a counter because the total number of things in my list is exactly all of the numbers in the sequence. So I don't need to have a special counter. I can just say if vals.size is greater than 100, because that's the length that I was trying to test. Then I need a counter, which I haven't created yet, but we'll call it num long sequences. So num long sequences plus plus as a way of recording we have found another long sequence. And then I'm going to close my for loop. So the only thing I need to do is create this counter up here at the top. I wouldn't want to create it in here because that's going to reset my counter with every repetition. So I'd want to do it at the very, very top. So num long sequences equals 0. And that's it. So if you didn't get this structure in class, I would recommend, sit down, give yourself 10 minutes, and see if you can reproduce this same structure from memory. And the way you produce it from memory is you don't try and memorize every single line of code. That's not the idea. You remember the overall shape of the solution. And the overall shape of the solution is this. Because it's brute force, you're going to be looping over every single possible starting value. Then you'll have some code that will generate the sequence for that starting value. Then you'll ask if its length is greater than 100 and add to a counter. And then you can ask, okay, how do I make a sequence? Well, I know as long as the last number isn't 1, I want to make a new number and add it to the list. So a lot of people who didn't get the problem, they were missing this looping structure where you need a loop to generate the terms, and that's inside another loop that's visiting every single starting value. So if you're worrying about why you weren't getting it, this is the thing to focus on. It's focusing on the overall idea of the solution rather than individual details, like how do you make this bit work. I'm more okay if you are a little fuzzy on the individual details, but I want to make sure that you are thinking clearly about the big overall structure. Okay, good luck.